you everyone for coming to today's seminar. So Rahul is going to give his talk on interaction techniques between HMD and mobile phones for outdoor AR. And this is one of his last weeks here at the lab before he goes off to brightest shores over in MIT, I believe. So yeah, give a big hand for Rahul.
Thanks, Adrian. Hi guys, thanks for coming. Didn't expect so many people. Today's seminar topic will be interaction techniques between HMD and mobile phones for outdoor AR. Informally we call it COURIAR or COURIAR. So this is a collaborative project between the HITLAB and Black Bay. Black Bay is a mobile workforce solutions company. So basically, they are looking at innovative ways that we could apply our interactive technology to for making the next generation courier delivery guy. So so just going to touch some of the techniques that we had made during this project. My supervisors at the HITLAB are Gun and Mark, who have just been awesome throughout the course of my thesis. Anyway, so moving on, a little bit about myself. So I come from the tiny country of Qatar in the Middle East. Something that astonishes a lot of people here are the gas prices. The gas price in Qatar is 30 cents a liter, and whereas in New Zealand it's 2.2 or something. So yeah, if you like fast cars and good cars, Middle East is the place to be. Anyway, so after living in Qatar, I went to India, where I did my undergrad at the Indian Institute of Information Technology, Allahabad. Fantastic place, great experiences. I learned a bit about coding as well, I guess. Anyway, then finally, after I got done with my undergrad, I went to Singapore, where I got a real nice chance to work with Professor Adrian Cheok at the Mixed Reality Lab Singapore, and it sort of formed my the foundation of my AR background. Learned lots of cool and interesting things from there, and Singapore is a great place to be. Got lots of things to do as well, which is good. So anyway, moving on. So let's talk a bit about mobile augmented reality. So I thought a lot about what I could define mobile outdoor AR, but I guess it's just AR applied in an outdoor setting. Yeah, no-brainer. But among the common themes among the different applications are that they make use of the GPS position to track the user's position, and then from the GPS position we get the position in the virtual environment, and then trackers such as, for example, if you have a head-mounted display and if you have like a head tracker over there, or in the case of a mobile phone, if you have the gyros there, so they will help you to find the orientation of the camera in the virtual environment. And of course, the way that you could interact with the virtual objects, or just the UI elements on the screen, you could do it with a wide range of input devices. So here's like a brief overview of the different types of devices. So a project like the Tin Myth project, they used gloves where they had a marker over there to sort of determine their position in the virtual world. Also, just the mobile phone itself has also been used to translate virtual objects. So basically just make use of the gyros, and how much ever you move, it will sort of sense that and then translate the virtual object. Palm tops have also been used in the past, a decade ago actually. That was one of the most famous projects called the Turing machine, as you can see the image on the right. So there have been lots of input devices that have been used in AR, outdoor AR, sorry. Google Project Glass, it's definitely exciting times. Everyone's looking forward to it. It's releasing in a couple of months, and I think what's really great about it is the light form factor, and it's small, and we could probably move closer to the dream of having a lightweight head-mounted display, and that displays the virtual information at a really good resolution. So some of you sort of follow tech events might have seen a group of skydivers who died, I think, from a big height, and they recorded the whole skydiving session on a Google Hangout, and they streamed it across to Google. So that was a pretty exciting video. And then recently there was a New York Fashion Week where there were models who were moving around with the Google Glass in different colors. And then at the end of the event, they just took all the videos and edited it out and from just the footage of Google Glass. So it was pretty interesting and to see like the video that was just the raw video that was captured from the Google Glass, and it was quite impressive. But from some of the information that we have received, and like I think Mark has also in fact visited them, we know that it might be possible that they're going to release it as an independent device. So using a head-mounted display as an independent device, would you purchase that over a mobile phone? So I think that's a big question that we're trying to ask here. So some of the previous research that has been done on this was evaluating display types for AR selection and annotation that was proposed by Wether from the University of California, Santa Barbara. So what they did was they evaluated a head-mounted display, a tablet that is used as a magic lens. So magic lens is basically just hold up the tablet and you'll sort of see the virtual world on the tablet, and they call it the magic lens. And of course a tablet at the waist level, as is shown in the third image. So what they did is they evaluated these three display devices for two tasks. One was visual search. So what they did was they had like lots of letters, and also they had like that very famous game called Where's Waldo. So they sort of just switched between those two tasks. And of course, another task that they had was cursor movement. So as shown in the third image, you can see lots of dots. So what they asked the users was to just connect the dots by using a head-mounted display. They had like an input device and the tablet as a magic lens and tablet as like on the waist. So what they did was they just asked the users to do these two tasks using the three display devices. So some of the results were expected, like for example, cursor movement, while magic lens was much better. So if people who were asked to join the dots using the magic lens, they were able to do it easily because it's just all a matter of just going around with the tablet hand, just clicking on the screen and then joining the dots. Whereas with the head-mounted display, you would have like an input device, look around, and then maybe sort of just use like a tracker or something, and then just try to click using it. So using a magic lens was intuitive, so it was not surprising. However, for visual search, well, what you would expect is that a head-mounted display would be very good, like because it's faster to just search around and then just find things. But apparently, there was no significant difference found between the different devices, say a magic lens or even the tablet held at a waist level. But this research was conducted 4 years back, and you can see the head-mounted display there. It's not like the head-mounted displays that we have today, because there has been lots of development in that field, like now, which is eventually culminating into the Google Glass. Also, there was another very interesting thought by Laramie, and he described in a journal paper about just rivalry and interference with the head-mounted display. So what he said is, if you have three objects at different focal distances, and if you just put text on it, so how readable it would be. So usually when you have an AR scene, and then we have objects that are located really far, and then we put text on them, and it all seems clear. But then what if it was like you're looking at an apple on a table, and then you have some text on it? It wouldn't be that clear, like as how he has shown here. Like you can see the A, it's sort of not that clear compared to, say, the H, which is in front of the tree. So this is so when you just talk about glass or head-mounted display as an independent device, so it's good for virtual images, visual guidance. For example, if you just have an arrow which is guiding you to the closest destination, and say if you have a 3D model which is augmented, it's good. The head-mounted display can be really good for that. However, let's say if you have a virtual keyboard and you have to type using the touch panel on the side as Google Glass has, it would be quite difficult. And say if you had to even use it as a mouse just to browse around the scene, I mean, it would be quite difficult to get used to this touch panel that would be over here. And of course, the fact is just one-dimensional as well, and it's small. So this is clearly, I mean, you can differentiate between these two, but text is a bit hard, as you saw with how Laramie had talked about. Text can be difficult, but then maybe if you could just have, you could sort of play around with the background, and you could put like, say, for a dark background, and then on top of the real world scene, and then put like a text in a light foreground, and then you might be able to get away with that. And if you just have like 2 or 3 lines of text, it would be all right. But if you have more text, then of course it's not that good. So there are lots of factors. So text may or may not be good. So I guess there are lots of limitations and good things about a head-mounted display being an independent device. But what if a glass or a Google Glass or head-mounted display would be an accessory to mobile phones? So mobile phones nowadays have just coming up with much better and better screens with a larger pixel density. Text is, of course, very easy to read on mobile phones. Text input, like everyone is able, we can just like send text messages very quickly on mobile phones. If you would imagine having a head-mounted display, and then you would sort of just using the touch, you would use the touch panel to type text in, and of course, moving a cursor on the screen of your mobile phone, which is 2-dimensional, would be much easier than if you just had like a 1D touch panel on the side. So, so I guess we could sort of combine the use of a head-mounted display and a phone, and you could come up with some very interesting applications. So this has been like the major focus of my thesis. And so just to sort of sum it all up, I wanted to explore some natural interactions between a head-mounted display and a smartphones, and also I would also like to use the phone as an input device to interact with the virtual elements that are displayed on the head-mounted display. And since our project involves us working with Black Bay, so we want to take this system and develop use cases for the courier service industry. I think this is all thanks to Mark, who showed me the video of the Nokia City Lens. So when you talk about natural interactions, I would like to point out this.
This is where City Lens comes in. One tap gets me into the app. One more tells it what I want. That's when the camera turns on, overlaying all the close restaurants around me. The distance, star rating, and name of each location appears in a crisp, easy-to-read menu. When a series of locations are next to each other, I just click on the stack and expand all of those restaurants out. If augmented reality isn't your style, tilt the phone 45 degrees to bring up a list of those locations. Not only do you see the aforementioned distance, star rating, and name, but City Lens also shows you which direction the location is in. Finally, if I tilt the device parallel, City Lens shows a map view and shows me all the relevant locations around me. One click on a location, and I get an estimate of how long it'll take to walk there. At any time, I can switch between these views without tapping through menus or waiting for content to load. It's simple, fluid, intuitive, and gets me to the information that I want that much faster.
So as you can see, like, I mean, they could have easily made, like, say, one dashboard interface, and then you would have 3 icons where you would click once for a map view, once for an AR view, and once for a list view. But they sort of combine the whole, all these 3 things into one device, and it does seem natural. I mean, it makes a lot of sense. So what we wanted to do was just to use this concept and apply it to a head-mounted display, a monocular head-mounted display, and a phone. So, and also one of the properties of the retina projective displays. So, for example, Google Glass, they have this property where if you show anything black on the head-mounted display, and if you just turn up the brightness real high, it becomes transparent. So, for example, in AR, we usually have this problem where you would put a camera over here, capture the real world, and then sort of put that as a background, and then maybe draw all the virtual elements on it. So, but what you could do instead is you could not record the image of the real world, and you could just like make it black or non-black, because these retina projective displays make the black color transparent. So anyway, moving on. So what we did was we developed 4 configurations for which like users would use this hybrid system of having a mobile phone and head-mounted display. So the first configuration is when the user is not looking at the handheld device, he's looking up at the AR scene. So what the head-mounted display would just show like a normal AR view, and the handheld device would be like a controller. So all like finger gestures that you would sort of put on the phone would be mapped to the AR scene. The second configuration that we have was what if the user looks down at the handheld device and the device was held in like a landscape view. So what we would show in the AR view, we would just make it black. The screen is black or just transparent, and so that the user can just basically see through the glass. He doesn't see anything, and he can sort of concentrate his attention on the phone, which would show the map view. Also, what if the user was looking at the handheld device, and however the device would now be held in the portrait mode. So here he would see basically a list of all the places that he would have to go, or like some nearby restaurants, as in the case of the Nokia City Lens. And of course, the head-mounted display would be black so that the user can just concentrate on looking at the handheld display. And finally, what if the user was looking at the AR view, and he didn't want to look down on the mobile phone? Instead, what he wants to do is he just holds up the phone like this at a 90-degree angle, and he's looking at the AR scene. So what would happen in that case is the head-mounted display would show the AR view, but the handheld device would now show extra information about the place. So this way, he could avoid just going down, looking at, he could avoid going at the list view and then selecting the place to find out more information about it. So all of these 4 configurations we think would be quite natural. So kind of apologize that like I made a very quick and very scratchy video, but this is like kind of what I have right now. So when the user looks down, this AR view is black so that I can fully focus down. And when I look, so when I'm looking down, the map view is shown over there. And when I look up, the phone is a controller. So now I'll show you what I mean by a controller. So basically, you can see those small red circles there. They are like my fingertips, and I could sort of just maybe use it to manipulate some information on the AR scene. I haven't shown all the configuration because I just made a very quick video, but just to give you the idea. But in case anyone is interested, I have a demo of it, and I can show it to you if you want. So this was the first topic that we explored in our thesis about natural interactions. Then we also wanted to look at the kind of gestural interactions which someone would want to perform while using a handheld mobile device and the head-mounted display. So why would someone want to do that? So some of the reasons that we could think was like maybe there's a building, and so since we are sort of building for a courier, the courier can actually just scale up the building and see how many packages he wants to deliver. So BlackBay has mentioned that they normally to one place they might have to deliver 20 or 30 packages. So let's say that if you have 2 buildings just next to each other, where one you see like a ton of packages, but you're just walking towards it and you want to just quickly get an idea how many packages you want to deliver. So you could just scale up the model and just keep walking, and you could probably see like, oh, okay, there are about 20 or 15. Whereas if it was scaled down, then you would just see like tons of packages very close to each other in the AR view. Another reason is, suppose if the courier, they often make some notes when they go to different places. So for example, say someone has given a location of a place, but it's not very accessible, as in like you have to sort of go in through a trail. So some couriers leave a note like, oh, okay, please take a right from so-and-so fence, or watch out for the dog, or something like that. So if suppose the courier has placed a tag and his friend comes and he sees the tag and he decides, oh, this tag is in the wrong place. So maybe someone would like to manipulate the virtual information by just sort of pushing it somewhere else. So that's another use case. And finally, if the user sees a virtual object in the AR view and he just wants to quickly get information of that object without having to go into a list view, and even without doing this. So how would we do that? So we made a list of gestures for this. So right now we have the following gestures. One is the single tap or the sticky finger. So what it's just basically you take your finger on the virtual object, you hold it there for 1 second, and then you can just move the object around. Pretty straightforward, I guess. Then of course you have the scale up and scale down. So you can just sort of use the pinch zoom effect to scale up or down the virtual models. And there's another gesture that is called the head crusher. Apparently, it originated in a TV show in the 80s. I just found the video yesterday and I thought it was quite hilarious. Show it to you quickly. You had this guy who used to just stand in some random place and put his hand up.
Hey, Wall Street, don't panic. I mean, I'm only crushing your heads. Crush you.
Apparently it was.
What the hell you guys find to talk about anyway?
I like to put my money in the technical. Well, I like to put it in the gun.
Anyway, so that head crusher gestures was adopted in a very famous paper written in '99. It was called the head crusher, and I think Mark had pointed me out to it. So it's a really good way of selecting objects in the virtual world. Of course, I wouldn't imagine dragging that on the touchscreen. So we sort of have developed a small hack for it. And of course, there was another gesture, set of gestures that we call the cross-dimensional gestures. So, for example, if you have an object selected, if you have an object in the AR view and you just want to get information of it on your handheld device, so you just swipe through. So you just select the object and just swipe it back to your handheld device, where you can see like a high-resolution image of it, maybe some information, etc. So a video of all those 4 gestures that we developed. So this is the interface that we have. So you can see the red circles over there that are the fingertips. And right now I'm just moving. And this is the head crusher. So I put 2 fingers and I just move the object like that. But then I can also like just take 1 finger up and I can move it around as well, because that might be much easier rather than using 2 fingers. Then we have the scaling up and down, as you can see. And finally, we have the cross-dimensional gestures. So if we just swipe, and while swiping we pass through a model, it will bring up this display, which will have details about the augmentation. So after that, since we had a demonstration that we had to make, so we developed this user interface for COURIAR. So as you can see, like right now, the couriers have to log in before they start their job. So that's why we have a login ID and a password field. And then when they successfully log in, that brings up a dashboard where they have messages, a map view showing where they have to go, and of course a job list if they just want to see like a list view. And we, with the help of Gun, of course, added a feature for adding notes into the scene. So for example, if the courier goes to a place, he can just touch it on the map view and then click the notes button, which will bring up this screen, and he can just add a note, which will just create like a plane in the AR view with details that he presents over there. So I've got about 2 weeks left, and we sort of want to make this framework more robust. So, and one additional feature that we want to use is to track the mobile phone's position. So I know that this might seem very not so apparent, like why would you like to track a mobile phone when you have the AR display here? But then I think this is all, when you think about it, there's the possibility that suppose if you're looking at a 3D model in your AR view using your head-mounted display, and let's say that you want to get a high-resolution image of that model, or say you want to see a zoomed in zoom in of the model, or an X-ray version of the same building, but through your, say, handheld device, which is which has higher resolution compared to your head-mounted display. So you just put your phone in front of your head-mounted display, and then you can see like an X-ray view or a zoomed-in view, whereas your AR view will give you a low-res just version of the augmentation. So it's a very good idea, and we'd like to thank Mark for helping me out with it. And I guess we just need to do a small user study and about the gestures that we proposed, and also have to complete the framework development and documentation. So in September 2012, we presented our next generation courier prototype system for the Post-Expo 2012 at Brussels. Unfortunately, due to certain reasons beyond our control, we couldn't demo it, but it was shown at the Black Bay UK, the head office, and we are just still waiting for feedback to see what people thought. But Rory, who is working on the courier dispatch interface, so his presentation and video were shown at the stand, and so we're just quite interested to see what people thought about the whole idea of a next generation courier dispatch and a next generation courier delivery guy. So it may not seem much, but then there are a lot of things that you can learn that I learned, and I think that could be useful. So, for example, when we thought that if we have to show something for Google Glass, we can just sort of use the Android phone, connect a head-mounted display, and make use of the awesome outdoor AR library developed at the lab. But then, unfortunately, that was quite difficult, and we had to switch to Windows. And we switched to processing because it would be easier for me to sort of write the code and do all the math on it. But then the performance was not as great, and then we had to switch to Open Frameworks, which I'm using today. Open Frameworks is definitely recommended, much faster and pretty easy to use. One of the students at the HITLAB, Sam Williams, has mentioned about GitHub and how awesome it is for using it to document your code. But then there's also this new thing called GitHub Pages, where you can sort of store documentation for your code on the website. So just by using GitHub, you can have your documentation, your source code, and it's really good for just managing code. And even like if you want someone to have a, you could just give someone the URL of a website and just tell them, okay, you have the code, the HTML documentation, etc. So it's pretty good, and definitely encourage everyone to try it out because it's free. And I would really like to thank Mark and Gun for just everything. Mark for, of course, just sort of steering me in the right direction and for brainstorming, and Gun with a lot of help with outdoor AR and just clarification of concepts when I had to switch from the Android library and just I had to implement all of those functions in Windows. So Gun was really helpful for me, so I would really like to thank them for that. And yep, thanks for hanging in so far. And if anyone has a question, please feel free to ask.
Should we give Rahul
If you sort of the last video you showed where you sort of showed gestures, just to know, I probably didn't really get it. So I had my glass and I had my phone. So do I look at the phone while I do those gestures or not? So I look basically into the wild. I have my augmentation somewhere there, and I want to interact with that fellow. How do I look at that? So I just stare and then hope for me to find it somewhere on the touch display, or?
Oh, I mean, I guess so you sort of assume that like you can just so they have like when couriers they have this long touchscreen device. So what I'm trying to say is like you can sort of hold this device like this. So we are thinking that you can apply the same concept while holding a smartphone, and then you can just use it to when you put your fingers, and you sort of assume that where you put your finger it will be mapped correctly to the AR view. So
do you just assume that, or is it?
Well, I mean, we propose it, I guess, and I think the user study will prove it. And maybe I think that maybe I'm used to it, so it might seem quite natural and intuitive to me. But
to add to the answer, actually the cursor appears on the head-mounted display. So the whole surface of the phone is mapped to the display on the head-mounted display. So it's appeared as a cursor on the.
And then you showed sort of, okay, well, you did the selection, and then you move So how do you map the movement? Do you map it sort of, because then you do a 2D movement and you want to map it to a 3D environment. So how does that work?
Oh, that's actually quite a good question. So the two aspects of it. So right now what we're doing is we're just trying to map 2 dimensions. We don't want the user to sort of alter the altitude. It doesn't make that much sense to, change the altitude. So what you're just trying to do is move it in the X and Y plane. And so for now, I have just mapped like, so if I move across the screen the horizontal direction, it changes the X, and if I move it up, it changes the Y. But ideally, actually even Gunn has it pointed out to me rightly so, when I move the object in the AR view to the right, it should move in the same direction as what I'm trying to achieve over here. So for example, if there's an object over there and the X is somewhere over there, it shouldn't just change it like that. It should move it relative to the movements that I do on the screen.
And it moves it only to the, depending on my movement on the screen. So if I select an object and I just move my head, then is the device still mapped to my viewpoint, and then the objects follow with my viewpoint change?
Oh, well, I think like we didn't add this condition, but I mean, I'd pretty much sort of just make sure that only if the object is visible in the HANDHELD display, then only it can be manipulated. So you can't like say hold something.
So if I just change my viewpoint and the object is been out of my view, will it then still what will happen?
It'll probably just not translate it. Then wouldn't translate.
I think to this, I was thinking about the possibility, for example, instead of having the mobile phone, to project like an imaginary screen where you can, I don't know if that will be possible to do, like projecting like an imaginary screen where you like interact as you with the mobile phone, but in the space. Like for example, imagine that here you have like to the screen of the, and then whenever you move, also your change of the. Understand what I want to mean?
Oh, I think so. You mean like projecting onto a wall or something like for the map?
You have your mountain display, and instead of having the 2D screen of the mobile phone, projecting like an imaginary 2D screen here, like in the half meter in front of you, and then trying to more or less knowing where your hand is positioned in this space, and to interact as you would do here in the mobile phone, but there, I mean.
Oh, okay. I sorry. Yeah, I got you. I think like so. One key thing is of course the performance that we are concerned of. So like for example, now we are not using computer vision, and now once we turn on the camera, then you have to use computer vision to track the finger, and then many cases for also like you would probably use something like background segmentation. So what if you have a light background and your finger is here? Maybe it won't be able to distinguish. So I think it's like it's of course a great idea to do it, but then it's like the performance wouldn't be as good and reliable as when you would compare like a small mobile phone to it. Yeah. So.
When you say this kind of gesture that you say this, how it's called?
Head crusher. Yeah.
And how you distinguish between that and when you want to scale something?
Oh, that's yeah. So what we have done so far is like when you do a head crusher, you have like your fingers like vertically like this, whereas in scale, whenever you do a pinch zoom, you always have to sort of like align it, like probably rotate it at like a 45 degree or 20 degree angle. So right now we just have the two fingertips are like just sort of like located just down or say within a range of 20 or 10 pixels. We perform the head crusher, whereas if you just tilt your finger a little bit and you do just like that, it just does a pinch gesture.
If you don't work with the Z-axis at all, how do you deal with hills?
Sorry?
If you don't work with the Z-axis at all, how do you deal with hills in an outdoor environment? Hills.
Oh.
Well, maybe the augment.
So if you're moving an object,
Yeah.
and you aren't using Z, the height, when you're moving it on a hill, or you're not going up to a little project?
Oh, well, I think like when you have like a virtual object, it will always be in front of you. So even when you have like a hill, it will be like as if it's projected in front of you because
you're assuming that Z plane fits.
So I think it's definitely needed to have some kind of control to control the virtual height. But at the moment, the current implementation doesn't count that. One of the possibilities, one of the works Rahul mentioned earlier, they haven't explained in detail, but they use the surface of the plane as a reference plane where you manipulate the object. So if you hold the phone in vertical way, then and do a gesture on top of that, it will move. The object will move on that reference to that plane. So you can move the phone in different pose and then do the 2D manipulation with that reference.
No problem. A simple way, just by having like a two-finger swipe or something, so it's left, right, or X, Y, and then Z is with a two-finger swipe or something.
Oh yeah, sorry, I just got your question now. When they were talking about, give a wrong answer. Yeah, I think if we haven't thought about it, like right now, yeah, we haven't thought about hills, so we just, yeah, that's a pretty good suggestion. Yeah,
so in your list of configurations, you have four different configurations.
Yep.
Have you thought about where you're looking down instead of setting the head-mounted display be blank to actually providing you extra information as opposed to just going blank? So when you look at your screen, because there's like limited space on a mobile device. Have you thought about that, and the use of that?
Well, I mean, I guess there are two ways of looking at it. Like, first is like, you just want to look at the phone and, you just want the user to concentrate on the screen and not like be bothered about everything. So, yeah, I mean, so there's, that's the reason why we just show it like as blank so that the user can just concentrate on looking at the high resolution mobile phone screen. And also, I think another reason is that even if we show some virtual details, maybe, I don't know, the weather or something at the background, or it would obstruct and it would be at a low resolution, and the user would actually have to. When you use a head-mounted display, it's quite different sometimes. So, you sometimes have to just stop and just squirm your eyes a bit just to see that, and we just think that it would be much better to make use of the high-resolution handheld device so that all his attention is just on this.
It's like a perception thing, like it's like back to the other slide where you had the blurry images and the more less blurry images, and the perception of that was quite difficult.
Yeah, that's right. I mean, it would be like, so it's just better to make use of high-res device.
So as long as you don't overlay that, do you think that it still might be useful? Or?
I think it could be useful if done in a couple of ways. But I guess in this scenario, it's just like, you have, when the user is looking down, he's definitely want to know where he's located or, the list or anything. So he might not be even concerned about the weather. I mean, if you could show, and all those details, if you could just show it on this, it would be much effective, I think. So that's the logic behind it.
All right, well, if there's no more further questions, we'll give Rahul another hand. And